Lesson 8, 9, perfect squares. In this lesson, you will learn to factor perfect square trinomials and solve equations involving perfect squares. Okay, so in previous sections, again, we learned that if you had a plus b squared, that's equal to a squared plus 2ab plus b squared. So today what we're doing is we're taking things like this and going back to that. Also the one that had minus that. Okay, so basically the idea that we want to do is we want to look at our first term and our last term and see if they're perfect squares. And then if we take the square root of the first term and last term and multiply each of them together times 2, and that's our middle term, then we know that it's going to work. So let's do an actual example so you can see this. So I want to look at my first term and my last term. Are they perfect squares? Yes, because 25 is 5 squared and x squared is x squared, and 9 is 3 squared. So this thing squared is 5x, or like the square root of that thing is 5x, and the square root of this is 3. So if I do 2 times this, do I get negative 30? I don't get negative 30, but I do get a positive. So what I want to do is say that this is going to be minus. So I'm going to say that this is the same thing as 5x minus 3 squared, right? Because if this was a and this was b, a times b times 2 would give you the center, which works. Okay, so because this one's minus is why this is minus here. So that is that thing factored. If I were to look at this one, again, I want to look at the first term and at my last squares. So the first 39 is the same thing as 7 squared, and y squared is y squared. So I can say that this thing is 7y squared. And this one over here, this is the same thing as 6 squared. So I want to know if I can do 2 times 7y times 6 and get 42. So that's 14 times 6. Which is 84, not 42. So in this case, this one is not a perfect square. Because this is not equal to 42y, this is not a perfect square trinomial. So we're just going to stop there and say not a perfect square trinomial. Okay. All right, so we just want to do a review of factoring methods. So remember, step 1 is always factor out the greatest common factor, if there is any, okay, no matter how many terms, okay? Step 2 is check if there's a difference of squares or perfect squares trinomial. So difference of squares is what we did in the last lesson, and this is the perfect squares. And that's going to be either if you have either 2 or 3 terms. And then step 3 is apply factoring patterns for x squared plus bx plus c, or ax squared plus bx plus c for general trinomials. Right? So when we're looking at this, remember, first step is always pull out any common factors. So I want to see if 6 goes evenly into 96. It does. It goes 16 times. So if I pull out 6, 6 is my greatest common factor, x squared minus 16. Now this here, that is a perfect square trinomial, or a difference of squares, right? Because this is a perfect square and that's a perfect square, and you're subtracting them. So what we did in the last lesson, we said this is going to be x minus 4 and x plus 4. Now that thing is factored completely. Again, first step is always to look for greatest common factors. In this one, is there anything that goes evenly into all of those numbers? I can't think of any. So we're going to use that method where we took A and C and multiplied them together. So 16 times 15, I get negative 240. So I want to know what times what gives me negative 240 and adds to 8. Okay, so if I were to do 20 and 12, that multiplies to 240, but I want one to be positive, one negative. I want to have the 12 be negative, so I could do 20 minus 12 and get 8. So I'm going to rewrite this as 16y squared plus 20y minus 12 minus 15. 12y, sorry. And so I'm going to group my first and my second two terms together, last two terms. And so between 20 and 16, the greatest common factor is going to be 4. And then between y squared and y, I can pull out a y. So I'm going to be left with 4y plus 5. And in this one, I can pull out a negative 3. And I'm left with 4y plus 5. So now I have 4y plus 5 in both. So I pull out 4y plus 5. And I'm left with 4y minus 3. Okay. Now that one is factored completely. For this one, I want to get everything equal to 0. Anytime you see the word solve, you should be thinking get it equal to 0. So 4x squared plus 36x plus 81, moving it over, equals 0. Now I'm looking at this, the first term and the last term, perfect squares. So 4x squared is the same thing as 2x squared, and 81 is the same thing as 9 squared. So I want to see if I can do 2 times 2x times 9 and get to 36. And that is 36x. So this one is a perfect square. So I can say that this is going to be 2x plus 9 squared. But this was equal to 0. So solving this, I'm going to take the square root of both sides to get rid of that squared. I'm going to get 2x plus 9 equals 0. And then I subtract 9. I get 2x equals negative 9. Divide by 2, and I get x equals negative 9 over 2. And that's that one. Okay, so we want to use the square root property, which is what I just did really quick right there. So if you square root both sides of an equation, so for example here, if you want to get rid of that x squared there, I can take the square root and that undoes it. But whenever you square root both sides, you have to say that it's plus or minus, because if you think about it, you can do negative 5 squared and get 25, or you can do 5 squared and get 25. So it's plus or minus. Either one works when you plug it in for x there. So using this method to solve this, I want to get rid of this squared. So I'm going to square root both sides. So it's going to be b minus 7. But this one here is always plus or minus the square root of 36. So the square root of 36 is 6. So I have b minus 7 equals plus or minus 6. So to get b by itself, I'm still going to add 7. So I get b equals 7 plus or minus 6. So when I want to solve this, I'm going to say, okay, what is 7 plus 6? And I'm going to say that's 13. But then I also say, what is 7 minus 6? And I'm going to get b equals 1. So 2 answers. For this one, again, to get rid of the square root, I'm going to square root both sides. And I get x plus 9, because the square root cancels the square, equals plus or minus the square root of 8. To get x by itself, I'm going to subtract 9 to both sides. So I'm going to get x equals negative 9 plus or minus the square root of 8. And I just want to simplify the square root of 8. So the square root of 8 is the same thing as 4 times the square root of 4 times 2. And that's the same thing as square root of 4 times the square root of 2. So you could apply the square root to both parts and get 2 square root 2. So I'm just going to say my final answer equals x negative 9 plus or minus 2 square root 2. And I'm just going to leave my answer like that. Okay, last one. A book falls from a shelf that is 5 feet above the floor. A model for the height h in feet of an object dropped from an initial height of h 0 feet is h equals negative 16 t squared plus h 0, where t is the time in seconds after the object is dropped. Use the model to determine approximately how long it took for the book to reach the ground. So if the book reached the ground, then we can say that the final height is going to be 0. And it started at 5. So I'm going to say 0 equals negative 16 t squared plus 5. And I want to solve this. So what I want to do first is, because I have no other t's, this thing doesn't factor anymore. I can't factor this. There's nothing common to pull out. They're not perfect squares, so I want to get t by itself. So what I'm going to do is subtract 5. So I have negative 5 equals negative 16 t squared. To get t squared by itself, I'm going to divide both sides by negative 16. So I'm going to get t squared now equals 5 over 16. And so to get t by itself, I'm going to square root both sides. Remember, it's plus or minus. So t equals plus or minus the square root of 5 over 16. Square root applies to top and bottom, so that's going to be the same thing as plus or minus the square root of 5 over 4, because the square root of 16 is 4. And then I can leave my answer like that. We're talking about time, so you can't have negative seconds. So I could actually not use the negative one, and I'm just going to use the positive. And so if I were to plug in my calculator, square root of 5 divided by 4, I'm going to get 0.559. 0.559 seconds. So you can say it's about 0.56 seconds. And that's your answer. Okay, and that's this section.